In this video, we're going to demonstrate methods of transporting heavy equipment once it arrives on your project, how to cross floor transitions and gaps like a freight elevator threshold, and how to lower a piece of equipment to the ground for installation. We will show how to safely and properly use a pallet jack, skates, and roller lifts. The specific processes shown in this video may differ from methods used on site due to site-specific conditions, tool configuration, transition equipment used, or manufacturer's recommendations. Please confirm with your supervisor and review the process for your tool or machinery move as outlined in the pre-task plan prior to moving any equipment. In this example, we're going to demonstrate moving a unit across an elevator threshold without putting the load directly on the threshold, also known as jump skating. This process can be used for transporting a load across thresholds, gaps in flooring, and other obstacles. The first step is to locate the unit's center of gravity so the pallet jack will support the load without the risk of tipping. Even if it has a center of gravity sticker on it, you need to assess the unit to find the actual center of gravity. This can be done by removing the panels to look inside to see where the weight is distributed, and by slowly raising the unit with the pallet jack to find where the majority of the weight is located. If the unit starts to lean as you raise it, reposition the jack and try again. The center of gravity should be placed toward the handle end of the pallet jack, and the load should be pulled, not pushed. If the center of gravity is placed toward the end of the forks, there's a greater risk of tipping the unit over the forks if a wheel is caught on debris. To prevent the unit from sliding on the jack, place friction pads on the forks where the load will be supported. You can use rubber pads, cardboard, plywood, or anything else that will increase friction between the metal forks and the metal frame. We're going to use this steel plate to simulate the threshold of a freight elevator. This operation can be done with or without the steel transition plates, since the wheels of the pallet jack will never be under a load while crossing the threshold. As we roll the unit up to the elevator, stop just before the wheels reach the gap between the floor and the elevator. Lower the jack and roll it into the elevator until the wheels are just past the gap. Reposition the friction pads and raise the jack again. Continue rolling into the elevator and stop just before the wheels reach the gap. Lower the jack again and slide the pads back so the jack can be rolled fully under the unit again. Raise the jack, again roll back into the elevator and stop just before the front wheels reach the gap. Lower the jack and pull it so the front wheels are just across the gap. Reposition the pads and raise the jack. Now we can roll the rest of the way into the elevator. Here's a view looking through the unit to see what's happening underneath with the pallet jack. Notice that the wheels are never under a load while crossing the threshold. To exit the elevator, rotate the unit 180 degrees and repeat the same steps again. Here's what the whole process looks like in fast motion. In this example, we're going to demonstrate moving a unit across a gap or threshold using steel transition plates. This is a quicker and simpler method than the jump skating method, but is not recommended for traversing larger gaps. There are a few ways of doing this. One option is to place one 1/8 inch plate in line with the gap and two 1/8 inch plates in line with the pallet jack. This is appropriate for crossing smaller gaps up to 1.5 inches. For gaps up to around 2 inches wide, placing two plates in line with the gap is the better option. Multiple plates may be needed to safely and stably support the wheels across the gap or floor transition. If you need to stack two plates, make sure the first plate that the wheels will roll over overlaps the second plate. If the gap you're crossing is wider than 2 inches, 1/4 inch steel or aluminum plates would be required. You may also need 1/8 inch plates to transition onto the thicker plate. Or you can use the jump skate method by lowering the unit and rolling the jack onto the plate and then raising the load again. However, in that case, it would likely be better to use the jump skate method previously shown that doesn't require plates. Before raising the unit, use friction pads between the pallet jack forks and the unit to prevent the unit from sliding. When assisting the pallet jack operator in pushing the load from behind, push with your hands as low on the unit as comfortable to help prevent tipping. Also, maintain constant communication with each other to assure there are no assumptions about what is happening. For plates thicker than 1/8 inch, stagger the plates slightly and maneuver the jack so that one wheel hits the plate at a time at about a 45-degree angle. Do the same for the rear wheels by steering the front to allow the rear wheels to hit the plate at an angle instead of straight on. It takes less effort to get the load on the plates one wheel at a time. Let's look at this method from above to see exactly how the pallet jack is steered. The wheels are hitting the plates at an angle and easily rolling onto them. If you're moving a piece of equipment that doesn't have permanent runners attached, use wooden blocks with magnets bolted to them as stabilizers. Place these blocks under all four corners of the unit and raise the pallet jack so the blocks are just off the floor. If the equipment starts to tip as it is being transported, the blocks will hit the floor and prevent the unit from tipping over. This is a demonstration of how to use roller lifts to move a transformer and how to cross a threshold or other floor transition. The two roller lifts work together to stably lift and support a piece of equipment while providing great maneuverability. They're placed on opposite sides of the transformer and are strapped together to secure the load. The hydraulic jacks are used to raise the load just enough to safely transport and maneuver the transformer. To start out, the forks should be spread as far apart as possible and placed under the equipment at the manufacturer's recommended lifting location. The pegs on the forks should be located so that they secure the C-channel under the transformer and prevent the load from sliding off the forks. If the unit you are transporting doesn't have C-channel or something for the pegs to hold onto, use friction pads to help prevent slipping. For the lifts to properly support the load, steel bars are used in between the lift and the transformer. This helps apply pressure to the edges of the unit where there's greater structural integrity. The bars should be long enough to extend past the edges of the unit for proper support, but not so long that they protrude too far and become a hazard. Without the bars in place, the pressure of the roller lift could deform the transformer, causing damage, and possibly allow the load to become less stable. Cardboard is used in between the bars and the transformer to prevent scratching the paint. While holding the bar and the cardboard in place, start raising the lift just until it takes some of the weight of the transformer. As it takes on the weight, it'll cause lateral pressure holding the bar in place. Now you can move on to the other side and repeat the same steps. Place the forks under the load and confirm that the pegs will secure the frame of the transformer. Hold the steel bar and cardboard in place while raising the jack until the roller lift has just enough lateral pressure to hold the bar in place. The next step is to attach the ratcheting straps on each side to cinch the roller lifts together and hold the transformer tightly in between. Use cardboard or other softeners in between the metal ratchet and the transformer to avoid damaging the paint. Tighten both straps until they're just snug. Once they are both snug, tighten them both until they securely hold the load, but not so tight that they cause damage to the transformer. Roll up the rest of the nylon strap and secure it to the load or the lift so it doesn't snag or catch on anything or create a tripping hazard. Now we're ready to raise the transformer. Raise both sides up at the same time so that both lifts are carrying roughly the same weight and the load is level. Raise the transformer just enough off the ground to clear any obstacles. Then test the maneuverability and stability of the load while it is still low to the ground. The lower the load is to the ground while moving, the safer the operation. In this example of moving into a freight elevator, steel transition plates are required since the wheels of the roller lift will cross the threshold while carrying the load. It is not possible to jump skate the load as we saw with the pallet jack. Place the transition plates in line with the casters and approach them at an angle so the casters hit the plate one at a time, thus reducing the amount of effort required to roll up onto the plate. Again, maintain communication while moving the load to ensure everyone involved knows what is happening. Here's a top-down view showing the angle used to allow the casters to roll onto the transition plates one at a time. This is a demonstration using skates to transport a larger piece of equipment. First, we need to assess where the center of gravity is and place a pair of non-steering skates at the heavier end of the equipment. A steel tie bar is used to help keep the skates aligned and prevent either skate from shifting or turning in case the load changes due to an uneven surface or debris getting caught under a wheel. Jack up the lighter end of the unit until the skates can be moved under the heavy end. To increase friction between the skates and the unit, place rubber pads on the skates. Plywood or other material can be used, but rubber is recommended for the best grip to prevent slipping. The skates should be centered under the steel that they will be carrying and aligned as closely as possible with the frame of the unit. Roll the skates back until they are snug under the frame. This will help hold it in position while installing the tie bar. Slide the tie bar through both skates. Make sure the bar extends at least halfway through each skate so that it can't work itself out while the unit is rolling. Now lower the jack just enough to allow the unit to rest on the non-steering skates. The front steering skate should be aligned with the center of gravity. With this particular piece of gear, the center of gravity is not at the center of the frame. This is because of where the transformer is installed. Locate the skate as far forward as possible and as close to the center of gravity as possible while using the full footprint of the skate pad. Remove any blocks that are under the unit and lower the jack until the skates are fully supporting the unit. Check each skate to ensure they are fully supporting the weight by tapping on them to make sure they don't move. Double check the alignment of the skates to make sure they're pointed in the same direction. Place magnetic blocks under the unit as an extra precaution so that the unit is supported if it were to come off the skates or start to tip. Before moving the unit, walk the path that you will be taking and make sure there is no debris in the way of the skates. Look for screws, zip ties, or any other small objects that could potentially stop one of the skates. As you start to roll the unit, constantly watch the skates to make sure they're rolling as expected and not turning off of their intended alignment. If anyone sees a skate not rolling properly or any other potential issue, immediately communicate to the team to stop. Again, we're going to cross our simulated elevator threshold that is covered by steel transition plates. Steer the front skate to hit the plates at an angle so the wheels easily roll up onto the plates. Due to the shape of this unit, after the steering skate crosses the threshold, the steel plates need to be moved further apart to line up with the rear skates. Now we can continue moving into the elevator. Now let's see what this operation looks like from above. The front skate is steered onto the plates at an angle and easily rolls over them without any extra effort. We'll stop here to relocate the plates for the rear skates. Now we can continue forward. Notice the angle of the front steering skate. This helps the rear skate hit the plate at a slight angle, and the unit easily rolls over them. Now we're going to look at how to lower a piece of equipment all the way down to the floor for permanent installation. The first step is to move off of the skates onto wood blocks. Replace any of the magnetic blocks with regular blocks, since the weight of the unit can damage the magnets. Always remove the front steering skate first. This keeps the unit more stable on the two rear skates. Raise the jack near the steering skate. Remove the skate and replace it with 4-inch high blocks and lower the unit onto the blocks. Move the jack to the other end of the unit and raise it off of the skates. Place the jack as close to the center of gravity as possible. Pull the tie bar out from between the skates and then slide the skates out. Never put your hand in between the skates and the unit, or between the blocks and the unit. Grab the blocks and the skates by their sides to remove them. Replace the skates with 4-inch blocks and lower the unit onto the blocks. Since we are lowering the unit all the way to the floor, we need to adjust the toe height of the jack to the lowest setting. Make sure the front support toes of the jack are facing forward to prevent the jack from tipping forward and dropping the load. Raise the jack and replace the 4-inch blocks with 2-inch and lower the unit back down. We'll do the same at the lighter end of the unit. Raise the jack and replace the 4-inch blocks with 2-inch and lower the unit back down. Now back to the heavy end. Raise the unit off of the 2-inch blocks and lower it most of the way down. From here, we need to lower the unit onto the thinnest plywood shims that will allow the jack to slide out. We'll use a bar to get the plywood shims out and lower the unit onto the floor. This bar is designed specifically for this purpose. Use plywood under the bar to protect the floor, and raise the unit just enough to get the shims out from the heavier side first. Remember, grab the shims by their sides. Never put your fingers under the load. Lower the bar and work it out from under the unit. Do the same to the other side. Back to the narrow end of the unit. Raise it off of the 2-inch blocks and lower it onto plywood shims. Make sure you are using the same thickness of shims on each side. Since this end is narrower, we only need to lift with the bar once to remove the plywood and lower all the way to the floor. Here's a time lapse of this process, showing how the unit is lowered incrementally at each end and gently placed on the floor. We covered a few ways of crossing a threshold or gap in flooring. Choosing the best method will depend on your specific scenario. Carefully consider which method is most appropriate for your situation. A few things to remember. Don't rush. Keep the load as low as possible while moving. Use friction pads. Move the pallet jack slow and steady. You should never have to pick up speed to try to cross a gap or threshold. Maintain clear communication with everyone involved in handling the move. Don't take shortcuts, and never compromise safety. Special thanks to Omega Morgan for sharing their expertise and demonstrating these techniques for moving heavy equipment.